Hello science friends, we're back again for Unit 3. We're starting a brand new unit. It's 3.A.1 and it's a really simple kind of quick concept. It's about chemical equations. There are a couple of different ways we can draw and write a chemical equation and a couple of different things that they can help us see and represent and things like that. I'm going to jump off to the side so you can take down these notes and then I'll be right back. Okay, hopefully that was enough time for you. A chemical equation is any time reactants form products, or how we draw or show that reactants form products. Reactants produce products, so reactants are on the left side of the equation, products are on the right. There are three main types of chemical equations, and the type depends on what we want to show. So for example, our first type is molecular. Molecular shows a big picture of what's happening. This is where you'll get your concepts like a double displacement or a single replacement or combustion, things like that. These are big picture ideas. They show how the atoms interact to form new compounds. And the way we do that is we keep all the compounds together. We don't worry about aqueous or aqueous, as Tim Prost likes to say, because he is fancy from Stag. But as we showed, we just keep them all together. So, for example, this is silver nitrate plus potassium chloride forms silver chloride plus potassium nitrate. Alright, not bad. The AQs right here, those mean aqueous or aqueous. Except people will make fun of you if you say aqueous, just letting you know. These are the aqueous ones. And then S means solid. You could probably figure out that L also means liquid and G means gas, but we don't have liquids or gases, so I didn't show those. Alright, so this just shows a nice big picture. We have a double displacement here, or what's called a double displacement or double replacement. My AG and my K are switching places. They are displacing each other. They are doubly displacing each other. Alright. Ionic. Ionic is a little bit different. It more shows the movement of electrons and the changes in charges and how things are affected. And we're going to get into a lot of that more in the AP chemistry world. We really haven't touched ionic or net ionic yet. You didn't do it in honors, but we will do it a lot here. Alright, so what we do in ionic is we separate the aqueous ions. So here I have my aqueous ions that I separated out. And we do this because that's really how it is in water. If you think about it, when something is dissolved in water, that means that the water molecules have separated them out. So if something is dissolved in water, the water molecules have gotten in between, kind of like that annoying person at prom, and separated the date apart. So water has gotten in between and pushed these two apart. Alright, like that chaperone at prom has pushed these two apart. So they're really not together. Right? They're really not together. We draw them together in a molecular just to kind of show what's moving places, but in reality these things are not together at all. And we can see that here. So Ag and NO3 are not together, so it's Ag plus NO3. Same time K and Cl are aqueous, so they're not together, so it's K plus Cl. So all of these things are independently, independently floating around in solution. Now we get to the other side. AgCl has precipitated out. A precipitate is when a solid forms from solution. A solid forms from solution. So this precipitates out. It actually kind of looks like snow. It's beautiful. That's potassium and that's nitrate. They are again aqueous or aqueous, as Tim Prost likes to say. And so they're just floating around in solution as well. Now a net ionic takes this formula and simplifies it down. It really focuses on what's doing what. And it does this by what's called removing spectator ions. Spectator ions are ions that just like to sit there and watch. Kind of like spectators at a football game, right? Spectators at a football game are the same before and after. They just watch. They don't really affect the football game. I know you're going to get into all this, sports psychology, but let's be honest. Spectator ions are just ones that kind of just sit there and watch the reaction take place. We know how to identify spectator ions because they're the same before and after. So let's take a look. I have an NO3 minus here and an NO3 minus here. Those are the same thing before and after, so we're going to remove them. They didn't change. I have a K here, it's supposed to be a K plus. I have a K plus here and a K plus here. Same thing before and after. I remove them, they didn't change. Notice what's left is Ag plus. I don't have an Ag plus on the other side. I have an AgCl. This is not the same as this. Right? It would be like saying hydrogen is the same as water. No, it's not the same. It's part of water, but it's not the same as water. Hydrogen is an explosive gas that caused the Hindenburg, was one of the causes that the Hindenburg, erupted into flames. All right? Cl is not the same as AgCl. All right? That's a poisonous gas. That's a beautiful white precipitate. Looks like fresh fallen snow in your beaker. So, these are not spectator ions. They're not the same before and after. Before they were separate, after they're together. It would be like saying sodium and chloride are the same as sodium chloride. No, sodium is an explosive metal. Chlorine is a poisonous gas. Sodium chloride together is table salt. They're not the same thing separate as they are together. So I remove the ones that are the same, these spectator ions, and you'll notice that Ag plus a Cl minus yields AgCl solid. That's my net ionic equation. It is taking out all of the quote-unquote garbage, all the junk that doesn't affect your reaction, and focusing directly on the things that affect it, the things that are actually being done, or things that are happening to, stuff like that. All right, hopefully this cleared up a little bit. We are going to get a lot of practice into writing chemical equations and formulas, because guess what? Kind of important in chemistry. All right, hope you have a great day, and I will see you in class.